Hi everyone, we're going to measure resistivity today. We're going to measure the resistivity of nichrome, this piece of nichrome that I've got here. It's nickel chromium alloy, that's why it's called nichrome. So in our equation for resistivity we've got resistance, we've got length, we've got cross-sectional area. We're going to change the length of this wire and measure the resistance. So we've got our independent variable is the length and our dependent variable is the resistance. Then we can plot a graph and we can use a graphical method, but unless we have the cross-sectional area, we can't then use that gradient to find the resistivity. So we need to find the cross-sectional area first, and I guess we could do it afterwards, but we're going to do it first. You're going to need your micrometer, which I haven't got a micrometer. I forgot to pick one up from school, but I really hope that I picked one up for all of you lot. So you use a micrometer to measure the diameter. Now when we do that with a micrometer, we want to reduce our uncertainty as much as possible. So if I was to ask you how we can do that, well, I mean, lots of you will be able to tell me you take repeats and take an average, but you can't just take repeats of doing the same thing, you're going to get the same value. The problem here might be that the wire is not quite circular, and so you might want to measure, you do want to measure the diameter in different directions, different planes, just so that when you average it, that will average out hopefully. You might also find that the wire is thicker in some places than others when it's been drawn, and so you want to do it at different lengths. So you want to do it in 3 different places along the wire at 3 different angles. That's still only 3 measurements. You don't need to do 9 measurements, but just don't at 3 different places on the wire, but make sure you change the angle as well. Measure the diameter of the wire and use it to find the cross-sectional area. Students often struggle with this, so I'm just going to give you some top tips. You're measuring the diameter, you're not measuring the radius. Use the diameter to find the cross-sectional area of the wire. Yeah. And the other thing that I want to say is that you probably want to convert your diameter into meters before you put it into the equation, because converting millimeters squared into meters squared is more difficult than converting millimeters into meters. But just make sure that you've got your unit system sorted out. Okay, so once you've measured your diameter, I think what would be a good idea is we're going to use a tape measure, is to lay the wire out on the tape measure and tape the two together. If you ask permission of the person that owns the desk or table that you're using, then it's actually a very good idea to tape the wire and the tape measure to the desk so it doesn't move around. I'll just show you what I've done. So I've taped the wire and the tape measure to the desk, and I've made sure that I haven't put the tape in the intervals that I want. So I'm going to be going up, I've got 1 meter 20. So if I go up in 20 centimeter intervals, I'm only going to get 6 readings. So I'm actually going to go up in 10 centimeter intervals. And actually it will make it more accurate as well, because the wire is not going to get not going to change temperature quite so much if we start at 1 meter 20 and go down in 10 centimeter intervals. That'll be fine. I can get 8 or 9 data points in my table. So I started setting up the circuit already. Actually, I've got a plug into the power pack. I'm going to draw a circuit diagram. The ammeter, we want the ammeter plugged into the COM first, and then the 10 amp setting, and then that means you have to have this dial at the 10 amp setting as well. And if the ammeter or multimeter has got the H on it and it's not working, it's because the hold button's on, and if it doesn't turn on, it needs a new battery. You'll have to replace that, sorry. And then I've connected up to the end of my piece of nichrome here with a crocodile clip, right? And I'm going to want to connect up the other end with a crocodile clip as well. But to get 1 meter 20, I'm clearly going to have to stack 2 leads together, because I've got quite short leads. Short leads normally make for really neat circuits, but in this case, they're not quite long enough. Right, and I'm going to put that at the 1 meter 20. And then the last thing that I need is a voltmeter, and the voltmeter needs to be connected either side of the wire, but that's obviously quite a long way as well. And so what I'm going to do is, I've already got 1 lead connected to the wire that connects to the ammeter, so I'm just going to connect the voltmeter to that side of that lead, to the wire side of the ammeter. Not that it matters really, because ammeters shouldn't have any resistance. and I've got this connector in the middle, so I'm just going to shove it in there, so then that will fit together. The voltmeter, then we connect it to COM first, we then connect it to the one with the V on it, and we turn the dial. We're looking for, this is the DC symbol here on the left hand side of the voltmeter. To turn that, we're going to be using about 3-4 volts. We're going to be using more than 2 volts anyway, and less than 20, so we want it on the 20 volt setting. And then I'm just going to make sure that my power pack is set at, let's go for 3 volts to start with. We want low voltage because we don't want it to get hot. We also want to only turn the circuit on for just enough time to get data. We don't want to be turning it on for too long because we're essentially short-circuiting the power pack with a piece of wire. So get a results table ready before you turn on, and then you just turn on quickly. So I've got 1.45 volts and I've got 0.1 amps, and that's at 1 meter 20. Okay, so you've got got to record 3 things. You've got to record the length, the potential difference in the current, and I want 8 different intervals at least, preferably more. I'm just quickly going to check that in my experiment I would get some variety in data if I just turn it on again. Yeah, so I've just turned it on at 60 centimeters and I have got different readings for voltage and current, so that's great. Leave an extra column in your results table for calculating resistance, because we're going to plot a graph of resistance against length. You find the gradient of that line, and using the gradient of that line and the cross-sectional area, I'm not going to tell you step by step how to do this because we should be able to work this out from y equals mx plus c, make it set that equal to the, get your equation in the form of y equals mx plus c, and you can hopefully then work out what the gradient represents, and use the cross-sectional area that you've calculated from your diameter to find the resistivity of nichrome, and then you can Google resistivity of nichrome and see how far out you are. So what I want to see then, I want to see, I want you to turn in your results table, your graph, and some comparison of your value with the value that you found online, please. Thank you very much. Nichrome, by the way, is just spelled N-I-C-R. Perfect.